Hey everyone, it's Mr. Wolfe here. Sorry I can't be in class today, but hopefully these video keys help you prepare for your formative tomorrow. So this would be scenario 4, and this is the case where we have you're pushing a table with your pinky. So if you're pushing the table, you're applying a force to it. So let's draw an applied force right here. Okay. And I probably should have made that really, really small because you're not going to be able to push really hard with your pinky. But there's my applied force by the pinky. And a few other things that I probably should have started off with is we're on Earth, so I'm going to have a force of gravity, and I'm also going to have a normal force on my table, right, by the floor pushing back up on the table. Now, since I'm pushing the table with my pinky, I know it's not budging, and that's because I have a force of friction going this way, and it should cancel out. So I'm going to draw these congruency lines right here. Okay, so if that's the case, right, my net force is going to be 0 because everything is balanced in the vertical direction and the horizontal direction, which means that my velocity is not changing. I don't have an acceleration, and my object was at rest before, so it's still going to be at rest. So what I actually did there is I kind of actually explained what you would do in your reasoning, but let's break this down because it's important that you guys not only can draw the free body diagrams, but this practices constructing explanations. So we want to work on this skill right here. So this, in general, this should be your thinking for writing your reasoning. What's your object's motion beforehand? Then explain the relevant forces in the free body diagram. And then from those relevant forces, is there a net force? And then answer that question using Newton's first law. How will this affect the object's motion? So let's apply this. So let's start with the object's motion beforehand. Beforehand, the table is at rest. It's at 0 meters per second. And then when I push the car with my pinky, the applied force equals the force of friction, so there's no net force. Right? So notice that I've hit those first 3 points right here in terms of my logical progression. So then I just need to finish it up in terms of, okay, well, what will my object do now as a result of this? Right? So because the net force is 0 newtons, the table continues doing what it was already doing and remains at rest. Right? So there would be my reasoning for my constructing my explanation. Right? So let's look at the second example. In the second example, I'm pushing with 2 hands, and so if that's the case, I'm going to have a much bigger applied force. And like I said before, since I'm on Earth, I'm going to have a force of gravity, normal force from the floor pushing back up, and you're still going to have friction, but if I'm pushing with both hands, that's going to overcome the force of friction. So I'm going to have something that looks like this. It's not drawn out right here, but my net force in this case, I'm going to look here and I'm going to say, okay, is there an imbalance in any direction? Nothing really going vertically, but it looks like what we care about is what's going horizontally, and there's definitely an imbalance, which means I have a net force going to my right. My acceleration, if my acceleration is always going to be the same as my net force, so 0, 0, to the right, and my initial velocity was 0. But actually, I'm going to wait to draw my velocity based on our explanation. So remember, we're going to use the same type of progression. So what's the object's motion beforehand? So before the table is at rest, right, then when I push with both hands, the applied force is greater than the force of friction. So at this point, I've explained the relevant forces in my free body diagram, but then I go on to talk about my net force. So I'm going to say, okay, which is greater than the force of friction, making a net force going to the right. And then the last part is, well, because there's a net force, the object changes its velocity. It will increase speed to the right. So I'm going to have my velocity going to the right as well, based on that. All right, so thank you for watching.